Dear students, before you start our lesson, we will update the knowledge. And to the frontal survey, I ask the questions and answer in English. Are you ready?
Yes.
What is the studying organic chemistry? Maqbal.
Organic chemistry is a chemistry subdiscipline for the scientific for study of structure, properties, and the reaction of organic composite, organic molecules. Study of structure determines the chemical composition and the formula. The study of organic reaction includes the chemical synthesis of natural products, drugs, and polymers, and the study of individual organic molecules in the laboratory and the real theoretical study.
Maqbal, thank you very much. Who is the author of the theory of the chemical structure of organic compounds? Uljalgaz.
The theory of chemical structure is the study of the chemistry which describes all its characteristics, which together determine the chemical behavior of a given molecule. This includes the nature of atom forms the molecule, the valence state, the order and the nature of chemical bond, the spatial arrangement, the characteristics of electron density, the nature of electron polarizability of electron code, the molecule, the main provisions of the theory of chemical structure, which is the theory, foundation of theory.
Very good, Uljalgaz, thank you. What are homologies and isomers? Uljan.
In organic chemistry and chemical series is a series components with the same functional group and similar chemical properties in which the members differ by the number of repeating units they contain. This can be the length carbon chain, for example, in strength chained alkanes, or it could be the number of monomers in a homopolymer, such as amylose. In chemistry, isomerization is the process by which one molecule is transformed into another molecule which has exactly this some atoms, but the atoms has arrangement A, D, A, B, C, B, A, S. In some molecules and under some conditions, isomerization occurs spontaneously. Many isomers are roughly equal in bond. Isomers who exist in roughly equal amounts, provided that they can interconvert somewhat freely, that this energy bond between the two is not too high.
Thank you, Uljan. Thank you, Uljan. Next questions. What is a chemical bond? What kinds of chemical bond do you know? Ulbosun.
A chemical bond, lasting attraction between atoms or molecules, and that enables the formation of chemical compounds. The stretch of as chemical compounds, there are weak bonds, secondary bonds, and primary bonds, such as metallic and ionic bonds, and dipole-dipole integrations.
Thank you very much, Ulbosun. Next question. What organic sometimes and called hydrocarbons. Gulzar.
In organic chemistry, hydrocarbons is an organic compound consisting entirely of hydrogen and carbons. Hydrocarbons are from groups 40 hydrogens. Hydrocarbons from which one hydrogen atom has been removed are functional groups called hydrocarbons. Because carbon has 4 electrons in it is almost shell. Carbon has exactly 4 bonds to make and is only stable. It is 4 of these bonds are used.
Thank you, Gulzar. Very good. Next question. How is covalent bond divided according to the number of common electron pairs? Sarah?
A covalent bond, also called is a molecular bond, is a chemical bond that involves the sharing of electron pairs between atoms. For many molecules, a sharing of electrons always 8 atoms to attain a stable electron configuration.
Yes, very good, Sarah. Thank you very much. Next questions. What is the definition sigma and p bond? Bignor?
In chemistry, sigma bonds are the strongest type of covalent chemical bond. They are formed by head-on overlapping between molecular details, and sigma bonding is the most typically defined for diatomic molecules using the languages and the tools of symmetric groups. In this formal approach, a sigma bond is symmetrical with respect to rotation about the bond axis. By this definition, common forms of the sigma bonds are S plus S, BZ plus BZ, S plus BZ, and DZ2 plus DZ2.
Yes, very good, Bignor. Thank you. Thank you for your responses. As I understand, you have learned the old things. Plan of the lecture. Classification of organic reactions. Classification of organic components. Nomenclature of organic components. Types of organic reactions. While studying organic chemical reactions, 2 aspects should be taken into account. What types of reactions exist and how are reactions processes. First, it is more reasonable to look at the types of reactions. Organic reactions can be grouped into several types according to the overall result. There are adenation reactions, elimination reactions, substitution reactions, rearrangement or isolation reactions, oxidation and reduction reactions, acid-base interreactions. Adenation reactions in which two substances react to form a single component. In this case, no atom is removed from both reactants. It can be generalized as follows. Addition reactions. This reaction is making AD. Addition reactions, AD. An example of the reaction is the addition of a halogen to an alkane. Alkane and ethylene plus reactant to give the two products. Elimination reactions. This reaction is melting A. Elimination reactions. This reaction is melting E. Elimination reactions. This reaction is melting A. Butane. Elimination reactions. The product ethane and ethylene. These reactions are among the most common and most useful ones in organic chemistry. An example of such a reaction is demonstrated by the action of an aqueous alkali and on glycan to give an alcohol. Rearrangement reactions or isomerization reactions.
Addition and substitution reactions. In this module, you will learn about the addition and substitution reactions of carbon compounds. Shown here are the molecules of two carbon compounds, methane and ethene. As you already know, methane is the simplest saturated carbon compound, whereas ethene is the simplest unsaturated carbon compound having carbon-carbon double bond. Let us see what happens when these two compounds are made to react with the same reactant, chlorine, under suitable conditions. Let's first check out the reaction of ethene with chlorine. The presence of the double bond makes ethene quite reactive. When we add chlorine to ethene in the presence of ferric chloride, the double bond of ethene breaks partially. The two carbon atoms in turn combine with one chlorine atom each, thereby completing their valency. The compound so formed is 1,2-dichloroethane and it is a saturated compound. Let's now check out the reaction of the compound methane with chlorine. When methane is made to react with chlorine in the presence of sunlight, one of its hydrogen atoms gets replaced by a chlorine atom. The product so formed is chloromethane. If the reaction is carried out with excess of chlorine and continuous exposure to sunlight, the chlorine atoms replace all the hydrogen atoms of methane one by one, giving rise to the products dichloromethane, chloroform, and carbon tetrachloride. So you have seen how differently chlorine reacts with two carbon compounds, ethene and methane. In case of ethene, the chlorine atoms add to the carbon atoms after partial breaking of the double bond. Since this reaction involves the addition of new atoms, it is known as the addition reaction. Ethene is not the only unsaturated compound that undergoes the addition reaction, but other unsaturated compounds also undergo the addition reaction under suitable conditions. These addition reactions of carbon compounds take place in the presence of some other compounds like ferric chloride, as in case of addition reaction of ethene and chlorine. Compounds like ferric chloride do not undergo any permanent change in them, but increase the rate of reaction. Such compounds are known as the catalyst. Some addition reactions of carbon compounds have industrial significance also. One such addition reaction is hydrogenation of the vegetable oils. Vegetable oils are long-chain unsaturated compounds. They undergo the addition reaction with hydrogen in the presence of nickel or palladium to form the vegetable ghee that are saturated compounds. Let us now get back to the reaction of methane with chlorine. Here, chlorine atoms replace or substitute the hydrogen atoms of methane. Since the reaction involves the substitution of hydrogen atoms with other atoms, it is known as the substitution reaction. Methane is not the only saturated compound that undergoes the substitution reaction. Many other saturated carbon compounds undergo the substitution reaction under suitable conditions. Since saturated carbon compounds are fairly unreactive, therefore, their substitution reactions take place in the presence of sunlight. Let's recap. The reactions that involve the addition of new atoms to unsaturated carbon compounds are called the addition reactions. Hydrogenation of a vegetable oil to form vegetable ghee is an example of addition reactions. Addition reactions of carbon compounds take place in the presence of catalysts. A substance that does not itself undergo any permanent change during a reaction, but increases the rate of the reaction is known as a catalyst. The reactions that involve the substitution of hydrogen atoms of saturated carbon compounds with other atoms or groups of atoms are known as substitution reactions. Substitution reactions of many saturated carbon compounds take place in the presence of sunlight.
Rearrangements and reactions consist in reorganization of chemical bonds and atoms in a reacting molecule on reactions of the molecular formula, formation of an isomeric product. This process of accompanies reactions of other types, but rearrangements in poor form are known as will form exemplar on hatching of aromatic allyl acids. Oxidations and reductions reactions defined in inorganic chemistry in a definite manner as compound with definitions in inorganic chemistry. Remember that in inorganic chemistry, oxidation is defined as the loss of electrons and reduction is defined as the gain of electrons. In organic reactions, it is not easy to its time with the electrons remembered from an atom or a date to it. The notion of an education number or oxidation state is necessary only for writing balanced equation. Classification of organic compounds. Organic compounds, open chain compounds, and cyclic compounds. Open chain compounds, straight chain compounds, branched chain compounds. Cyclic compounds, gamma cyclic compounds, and tetracyclic compounds. Gamma cyclic compounds are cyclic compounds and aromatic compounds. Saturated compounds having carbon-carbon sigma bonds. For example, methane, ethane, propane. Unsaturated compounds having at least one carbon, sigma and pi bond or multiple bond. For example, ethylene, acetylene, methylacetylene, methylethylene, methyl and acetylene, diacetylene. Gamma cyclic compounds having similar types of atoms in the complex cycle, whereas the tetracyclic compounds having at least one different atom. Oxygen. Homocyclic compounds having similar types of atoms in the complex cycle, whereas tetracyclic compounds having at least one different atoms, oxygen, sulfur, nitrogen, in the cycle. Alicyclic and aliphatic plus gamma or tetracyclic. aromatic compounds, for example, benzene, naphthalene, biphenol, atrazine, phenanthrene. Classification of carbon. There are 4 types of carbon present in organic compounds. The carbon which is directly attached with 1, 2, 3, and 4 carbon atoms are known as primary, secondary, tertiary, and quaternary carbons. For example, carbon directly attached primary carbon, 2 carbons attached secondary carbons, 3 carbons attached tertiary carbons, and 4 carbons attached quaternary carbons.
Open chain compounds are also called acyclic compounds. In these compounds, the carbon chains are either straight or branched. In a straight chain compound, one carbon atom is attached to no more than 2 other carbon atoms. As its name implies, the straight chain is a straight link of carbon atoms and may involve double and triple bonds too. Apart from carbon, other atoms such as oxygen or nitrogen may be present. Branched chains have at least one carbon holding more than 2 other carbon atoms. Branching is one of the reasons why there are so many isomers. Cyclic compounds or closed chain compounds are composed of 1 or more rings of atoms. For example, cyclopentane has 1 ring of 5 carbon atoms. Naphthalene has 2 rings made of 10 carbon atoms, and pyridine has 1 ring which contains 5 carbon atoms and a nitrogen atom. The conventions for drawing the fully condensed structural formula of cyclic compound are: in hydrocarbons, carbon atoms occur at every corner. They are not written. Remaining bonds of carbon are understood to hold H atoms. Double bonds are always explicitly shown. When oxygen or nitrogen or another atom is present, it is explicitly written. A line connecting 2 corners is a covalent bond between adjacent ring atoms. Homocyclic or carbocyclic compounds contain rings which are made up of only carbon atoms. These are further subdivided into alicyclic compounds and aromatic compounds. Alicyclic, carbocyclic compounds resemble the aliphatic compounds in most of their properties. Some examples are cyclopropane, cyclobutane, cyclopentane, cyclohexane, etc. Aromatic carbocyclic compounds are a special type of unsaturated compounds. They are classified as benzenoid aromatic compounds and non-benzenoid compounds. The benzenoid aromatic compounds contain one or more benzene rings and their functionalized derivatives. Depending upon the number of fused benzene rings, the compounds may be monocyclic or polycyclic. Benzene, toluene, nitrobenzene, phenol and benzaldehyde are monocyclic aromatic compounds. Naphthalene and anthracene are polycyclic aromatic compounds. Benzenoid aromatic compounds include biphenyl and terphenyl. These compounds have isolated benzene rings in their structures. The non-benzenoid aromatic compounds do not contain benzene rings. Instead, they have other unsaturated rings. Tropone, tropolone, and azylene are examples of non-benzoid aromatic compounds. Heterocyclic compounds contain one or more heteroatoms such as oxygen, nitrogen, sulfur, phosphorus, etc. in their rings. Depending upon the chemical behavior, the heterocyclic compounds are further classified into alicyclic and aromatic compounds. Alicyclic heterocyclic compounds are aliphatic cyclic compounds. Oxirane, oxalane, and oxetane are examples of compounds that contain oxygen heteroatom in their structures. Aromatic cyclic compounds containing one or more heteroatoms in their molecules are called aromatic heterocyclic compounds. Pyridine, furan, thiophene, and quinoline are examples of aromatic heterocyclic compounds.
Nomenclature of organic compounds. A. Common name or tribal name system. B. Derived name system. C. UPAC name or Geneva name system. Some common names based on source. Compounds: methane. Common name: merged gas. Source: merged place. Common name: methanol. Compounds: methanol, wood spirit, or carbinol. Source name: distilled distillation of wood. Acetic acid, common name: acetic acid. Derived name system. According to this system, name of any compound is given according to the representative compound of the homology series. This system of researches for following homology series. Name of homology series: alkane, alkane, alkene, alkanol, alkanyl, alkanoic acid, alkanoyl halide, alkanamide, alkanon. Name of representative compound: methane, ethylene, acetylene, carbonyl, acetaldehyd, acid, acetyl halide, acetamide, acetone. Structure of group. IPAC name system or Geneva name system. International Union of Pure and Applied Chemistry. Secondary prefix, primary prefix, root word plus primary suffix plus secondary suffix. cyclic components. The root word, it represents number of carbon atoms in select principal carbon chain. The primary suffix, it represents substance or unchanged in presentable carbon chain. For example, ethane, ethylene, and ethane. The secondary suffix, it represents main functional group. For example, rules for EUPAC nomenclature.
Rules for EUPAC nomenclature. Rule 1. Select the longest continuous chain of carbon atoms which have maximum number of subunits, multiple bonds, and functional groups. Priority order: functional groups, multiply bond or subunit. Rule 2. Selected principal carbon chain is numbered from the side where a subunit of multi or multiply bond or functional group is near. Priority order: functional group, double bond, triple bond, subunit. For example, 3-methyl pentanoic acid, 3-methylheptane, 2-isopropyl-but-1 in or 2-methyl-ethyl-but-1 in. Sum of functional groups always works as prefix. Prefix name: halo, alkoxy, epoxy, nitro, nitrose. Sum of functional group works as prefix and suffix. Functional group prefix carboxy and suffix ic acid. Functional group sulfo prefix sulfo, suffix sulfonic acid. Functional group suffix oic anhydride. Functional group prefix alkoxy carbonyl or carbaloxy, suffix alkyl oid. Functional groups prefix haloformul and suffix oil halide. Functional group prefix haloformul or halocarbonyl, suffix oil halide. Functional group prefix carbonyl or amido and suffix amide. Functional group prefix cyano, suffix nitrile. Functional group prefix carbyl amino, suffix isonitrile. Functional group prefix farnyl or oxo, suffix l. Functional group prefix keto or oxo, suffix on. Functional group of prefix hydroxy and suffix ol. Functional group of prefix mercapta and suffix tiol. Functional group prefix amino and suffix imino. Functional group prefix alkoxy. Functional group and suffix ane, ethane, acetylene. Functional group prefix halhakane and functional group prefix nitro. For example, three hydroxy, 3-methyl, butane, 2-1, 2-keto-propanol, 3-cyano-propanoic acid.
Nomenclature of organic compounds. IUPAC, International Union of Pure and Applied Chemistry, is the latest and widely accepted system for nomenclature of organic compounds all over the world. It has set certain guidelines for systematic nomenclature of organic compounds. According to this system, all organic compounds are considered to be the derivatives of saturated hydrocarbons, that is, alkanes. The name of a compound can consist of three components: root, suffix, and prefix. Root. This indicates the number of carbon atoms in the longest continuous chain. The root word for a compound with one carbon atom is meth. That with two carbon atoms is eth. One with three carbon atoms is prop. A compound with four carbon atoms is bute. One with five carbon atoms is pent. That with six is hex. One with 7 carbon atoms is hept. That with 8 carbon atoms is oct, and so on. Suffix. This includes the phrase after in the name of organic compound and has two parts, suffix 1 and suffix 2. Suffix 1 indicates the saturation or unsaturation in the carbon chain. The suffix for an alkane is ane. For alkene is ene. And for alkyne is ine. Suffix 2. This indicates the presence of type of functional group. The suffix for an alcohol is -ol. For an aldehyde is -al. For a ketone is -one. For carboxylic acid is -oic acid. Prefix. It includes the phrase before in the name of organic compound. This indicates the substitution of hydrogen atom H from the basic carbon chain by any halogen, fluorine, chlorine, bromine, iodine, or branching, methyl, ethyl, etc., and their position. Numbering. The numbering of carbon atoms in the chain is done in such a way that the first carbon is nearest to the functional group or branching or double or triple bond. The position of unsaturation and functional group is indicated along with the suffixes. Example 1. Let us name the compound C2H5OH. Steps. 1. For the root name, count the number of carbon atoms in the longest continuous chain and number them. In this example, only one chain is there with 2 carbon atoms, and thus the root used is eth. 2. Suffix 1. As all the bonds between carbon atoms are single, the first suffix is ane. 3. Suffix 2. The presence of functional group OH, that is alcohol will replace E of ethane by ol. Thus, we can call it ethanol. As the alcoholic group is attached to the first carbon, the name of this compound is ethane 1-ol. Example 2. Give the IUPAC name of following compounds. Solution. We will observe the following steps. 1. For the root name, count the number of carbon atoms in the longest continuous chain and number them as per rule. In this example, there is only one chain with 3 carbon atoms. Thus, the root used is prop. 2. Suffix 1. As all C-C bonds are single, suffix 1 is ane. Thus, it can be named propane. 3. Suffix 2. As the compound does not have any of the main functional groups, the name will remain propane. 4. Prefix. Hydrogen atom at the second carbon is substituted by a halogen bromine Br. Thus, prefix bromo along with its position will be mentioned in the name, that is 2-bromopropane. Hence, the final name of the given compound is 2-bromopropane. Solution. We will observe the following steps. 1. For the root name, count the number of carbon atoms in the longest continuous chain and number them as per rule. In this example, there is only one chain with 4 carbon atoms. Thus, the root name is bute. 2. Suffix 1. There is one double bond between first and second carbon atoms. Hence, suffix 1, ene, is added to the root word, making the name butene. As the double bond is present between C1 and C2 and the lesser number is C1, therefore the location of double bond is 1. The name of the compound will be but1-ene. 3. Suffix 2. As no functional group is present, there will not be any further change in the name. 4. Prefix. There is no substitution of any halide or alkyl group, so no further change in the name. The final name of the compound is but1-ene.
The final questions on the lecture. The final questions on the lecture classify the following reactions according to the types discussed before. A reactions is Ulgoson.
Enrichment reactions.
Yes, very good. B reactions is Sumbat.
Addition reactions.
Very good. C reactions is Uljan.
Elimination reactions.
Very good. D reactions is Ahmaral. D reactions is oxidations reactions or combustion reactions. Sit down. E reactions is isolate.
Redoxis reactions.
Very good.
Types of organic reactions and mechanisms. Organic reactions can be classified into the following categories. 1. Substitution reactions. 2. Addition reactions. 3. Elimination reactions. 4. Rearrangement reactions. Qualitative analysis of organic compounds. The elements present in organic compounds are carbon and hydrogen. They may also contain oxygen, nitrogen, sulfur, halogens, and phosphorus. Detection of carbon and hydrogen. Carbon and hydrogen are detected by heating the compound with copper to oxide. Carbon present in the compound is oxidized to carbon dioxide, tested with lime water, which develops turbidity, and hydrogen to water, tested with anhydrous copper sulfate, which turns blue. Detection of other elements. Lassen's test is used to detect the presence of nitrogen, sulfur, halogens, and phosphorus in an organic compound. The elements present in the compound are converted from covalent form into the ionic form by fusing the compound with sodium metal. Reactions taking place here are cyanide, sulfide, and halide of sodium, so formed on sodium fusion, are extracted from the fused mass by boiling it with distilled water. This extract is known as sodium fusion extract. A. Test for nitrogen. The sodium fusion extract is boiled with iron 2, sulfate, iron sulfate, and then acidified with concentrated sulfuric acid. The formation of Prussian blue color confirms the presence of nitrogen. B. Test for sulfur. The sodium fusion extract is acidified with acetic acid and lead acetate is added to it. A black precipitate of lead sulfide indicates the presence of sulfur. If nitrogen and sulfur both are present in an organic compound, sodium thiocyanate is formed. It gives blood red color and no Prussian blue since there are no free cyanide ions. C. Test for halogens. The sodium fusion extract is acidified with nitric acid and then treated with silver nitrate. A white precipitate soluble in ammonium hydroxide shows the presence of chlorine. A yellowish precipitate sparingly soluble in ammonium hydroxide shows the presence of bromine, and a yellow precipitate insoluble in ammonium hydroxide shows the presence of iodine. D. Test for phosphorus. The compound is heated with an oxidizing agent, sodium peroxide. Then the phosphorus present in the compound is oxidized to phosphate. The solution is boiled with nitric acid and then treated with ammonium molybdate. A yellow coloration or precipitate indicates the presence of phosphorus.
Next questions. What substituents do you know? Prefix. Mahpal.
Halo, alkoxy, epoxy, nitroxy.
Very good, Mahpal. Thank you very much. How many carbons? Bases. Bignor.
Four types. Carbons, primary, secondary, tertiary, and quaternary.
Thank you very much. Very good. What family of the suffix? What family of the suffix, Uljan?
Oil acid, sulfonic acid.
Thank you, Uljan. Gulzar, next, Gulzar. What family of the suffix?
Alkaloid, oil halide, amide, nityl, isonetyl.
Thank you. We conclude our lecture today to take into account your comments and suggestions. Please write a review about the lecture. Thank you very much.